Hi everyone, this lesson is about areas of triangles. Now, if we have a triangle like this, let's say this is angle A, so that's side little a. This can be point B, so that's side little b. This will be angle C, and that's side little c. Now, if I wanted to know the area of that triangle, you'd probably recall the old formula for area back in middle school was base times height over 2. Now that's great. We do have the base of the triangle. The base of the triangle here is length C, but I don't know the height of the triangle. So I'm going to have to add in a line perpendicular to the base going up there to point C, so perpendicular height. That's the height of the triangle. Now, how can I find the height of the triangle? Well, if I focus for a moment just on this section, so just the bit that I've highlighted there in green, if I focus just on that one, I have a right angle triangle. So I'm going to go across to the side here for a moment. Remember, this here angle, this is angle A. If I wrote the sine of angle A, sine is the opposite to that is height in the green triangle, hypotenuse is B in the green triangle, multiplying through by B, I would have the height equals B multiplied by the sine of A. The height of the original triangle is edge B multiplied by the sine of angle A. B and A were both from the original triangle. I can take that back. I might just capture that little answer there and move that to where I can see it. So I can take that back over here into this old idea. So the area of a triangle, well, the base was edge C, the height is B times the sine of angle A, all divided by 2, and that's the area of the triangle. It looks a little bit of a mess, doesn't it? Let's neaten that up. The area of any triangle, so I started with a scalene triangle. The divide by 2 is commonly written as half. Then the B and the C, we put those in alphabetical order so it's easier to remember, BC. And then the sine, always at the end, and the angle, capital letter for angles, is the one which is not there. That's my formula to calculate the area of any triangle I like. It wouldn't have to be a right angle triangle, a scalene triangle. Most importantly, if I had, and I'll just re-sketch here. Oh, I'm still in red. Oops. So that was A, that's the angle. B was up there, and C was down there. So the important bit is that the edges B and C, which are listed here, are the ones on either side of the angle A. So the angle A, turn green please, the angle A, we call it the included angle. It's the angle between the two edges which are named in the formula. Now, is there something special about me using angle A? No, there's not. I could equally well have written this formula for area as 1/2 will still be 1/2. Now, it didn't have to be edge B and C. It could have been edge A and B. As long as there were two edges, now any two edges in a triangle must have an angle between them. And what would be the angle between A and B? That would be angle C. We can go back to the original picture if we want to look at that. The angle between A and B, the angle between those two edges is angle C. Likewise, I'm sure you get the idea now. I could have, I could have AC as the edges and the angle between A and C is the other letter that's not there yet. It's angle B. So we don't need to memorize all three of those. If we memorize just this one here, then we can use the pattern to solve any triangle we like. That's the rule for area of a triangle, which is really, it comes from the old idea that we used to know, but it's better because it works in every single triangle we could ever find. Now there is one other thing to say about areas of triangles, and this is called Heron's rule. This is a good one. That last one was if we knew two edges and the angle between them. Sometimes we don't. Sometimes we have a triangle where we know all three edges. So we might say that edge A equals 4. Edge B equals 7. Now remember that old thing that those two edges add to equal 11, so the third edge would have to be less than 11. So that edge there, let's say that's 9. I think that will work out okay. There's three edges of a triangle. I don't know the angles. How could I find the area? Well, we use Heron's rule. The area of a triangle is S take A, S take B, S take C, all underneath a giant square root sign. And you're going to say to me, what's this letter S? And you'd be right. S is the semi-perimeter. Now, the perimeter of the triangle is A plus B plus C. Semi-perimeter means half of the perimeter. That's fine. So let's calculate semi-perimeter. A was 4, plus B was 7, 11 so far, plus C is 9, 20. 20 divided by 2 is 10. The semi-perimeter is 10. Now come back to here. I will have 10. S is still 10. Take away. A was 4. S is 10. Take away B was 7. S is 10. Take away C is 9. And still with a giant square root sign. Now we can calculate this. 10 take 4 is 6, 10 take 7 is 3, and 10 take 9 is 1. That's an easy one. So I have, let's see, 3 times 6 is 18, times 10 is 180. The square root of 180. Goodness, that's a lot, isn't it? Well, what would that be? I'm thinking of 9 times 20, but 20 is 4 times 5. It's the square root of that by square root of that by square root of that if I'm using surds. And so that's 3, that's 2, and root 5 can't be simplified. So I have 6 root 5 square units for the area of my triangle. Of course, I could use a calculator to give an approximate answer, rounding off to 2 or 3 decimal points if I wanted to. But that's the two different ways we have of calculating areas of triangles now. If you know all three edges and you don't know the angles, go for Heron's law. Works a treat. If you do know 2 of the edges and the included angle, go for this one here, 1/2 B times C times the sine of A. Just make sure that that angle you have is the angle between the 2 edges, and it'll work fine every time. That's enough for this lesson on areas of triangles. I'll see you next time. Thanks for watching.